It's thinking. Okay, can you all see that?
Yep.
Mm-hmm. Excellent. Okay, so I'm going to talk about this eclipse. It is now 2 weeks away. I've been working on this for years at this point, and I'm going to talk about why eclipses happen, why this one's a big deal, what you can expect to see, and just how ludicrously busy it might be on the Path of Totality. So I'm going to start by just talking about the Earth, Moon, Sun system, because we really need to understand that. When we have an eclipse, it's the moon getting between us and the sun, but we need to understand the system in general. So I'm going to start talking about just moon phases. So I hope you can see my cursor, but here we've got a full moon every month and a new moon every month. So this is the moon phase calendar for the entire year. And if we look at this month and where we're at, we're actually right about here. Full moon today, yay! Last full moon of the cycle before we get an eclipse. So we see these shapes, but I want to talk about why that happens. And that happens because, so here I've got the Earth, the sun is somewhere off of there, and the sunlight's coming in, and we get, if we have the moon in this position here between us and the sun, we don't see it because the lit up side is pointing away from us. But the moon goes around the Earth, so as it moves around, once it gets to here, we're stood on Earth, we're looking towards the moon, we see this little bit here, and it looks like a crescent. It's going to keep moving, so a few days later, now as we look at it, we can see this half lit up, that's first quarter, and it keeps on going until about 2 weeks after new moon, the whole of the lit up side is pointing towards Earth, and we can see a full moon. But the moon's going to keep moving, so this is where we're at today, and in a few days, it'll be getting smaller and smaller and smaller, till we get back to new moon. Now, we get a new moon every 29.5 days. So it takes 29.5 days to go from new moon all the way through all the phases and back to new moon. Now, if we're looking at this and the sunlight's coming in here and the moon's here, we might think that we should get an eclipse every 29.5 days, but we don't. So what we're going to get is, we need to think about this in 3 dimensions. We're looking at this from down on top. Now I want you to think about this. You want to look at the, actually, let me just see if I can stop sharing for a second so you can see me better. Okay, so you can see me bigger now, right? So imagine that you guys are the sun, my face is the Earth, and my fist is the moon. And for an eclipse, the moon has to be here, right? Now I cannot see all of you, okay? But actually, mostly at new moon, the moon is going to be down about here. So it's not blocking my view of the sun. I can still see the sun. Or it's up here. It's not blocking my view of the sun. I can still see the sun. But the moon has to go around the Earth. So if it starts down here and my head is the Earth, when it goes around, it's going to end up here at full moon. And that's also good because now we're not blocking the light to the full moon. So you guys can all see my fist. That means that sunlight hits the moon and bounces back onto the back of my head, which is the other side of the Earth. So that's what's happening most months. I'll go back to sharing screen again. Yes, really. There we go. Okay, so that's interesting. Can I move that? Yes, I can. All right, sorry. I now have things in funny places. Okay, so if we're looking at this from the point of view of what's going on, we've got here's the sun. Oh, no, go back. Here's the Earth, and they're in this plane, like a piece of paper, that is shown by this gridded portion. But here's the moon going around the Earth, and it's at a different angle. So it's at an angle like this. What it means is that we get something like this, where now the sun is coming in here, it hits the moon, but the moon's shadow doesn't hit the Earth because the moon's too high up. Likewise, the sun's light hits the moon, and we can see it from here, but we don't get an eclipse. We only get an eclipse when it's completely lined up, okay? So we get an eclipse like this. Now what you'll see here is we've got a solar eclipse when the moon gets between us and the sun, and a lunar eclipse when we get between the moon and the sun. But this really shows you why you're more likely to have seen a lunar eclipse. When we get a lunar eclipse, like here, the whole of this side of the planet, the whole of the part of the Earth that gets nighttime is going to see that lunar eclipse. But if we look at the solar eclipse, the shadow is much, much smaller. So only a much smaller fraction of the planet gets to see it. We actually get as many lunar eclipses as solar eclipses on a planetary scale, but you can see the lunar eclipse from a much bigger area. So let's talk about how often we actually get eclipses. Oh, no, go back. So now I've put the whole system together. I've got the sun in the middle. The Earth is going around the sun, all the way around. The gridded part is the plane that has the Earth and the sun in it. The moon is going around the Earth here, but if we're looking from the Earth to the sun, then the moon here would be down underneath it. So it's again like this position where the moon is in the direction towards the sun, but it's not directly lined up. But it stays at this angle. So what happens is, as the Earth moves around the sun, now when it gets to this position, the place where the moon is lowest below that plane is down here, and that's half full. When it gets back to new moon, now it's lined up and we get an eclipse. But the Earth keeps moving, so then the moon is out of alignment again, so there are no eclipses, really no eclipses. We're getting towards alignment and back around here, now it's lined up again, okay? So what's happening is that we're gonna get a lining up of the sun, moon, Earth twice a year. Now, we don't experience eclipses twice a year, so what's going on? There are two different things. One is that actually not every lining up is going to give us a total eclipse, and I'll come back to that later, but about half of them do. So almost once a year, we will get a total solar eclipse, but you have to be on the right bit of the planet to see it. So let's look at what that looks like. Oh, no, keep pressing the wrong button. So here I've got, here's the sun, here's the moon, here's the Earth. And if you want to be standing on the bit of Earth where you cannot see the sun at all, you have to be on this tiny little dark spot right here. That spot is only about 70 miles across. So even though we get a lining up like this, you might not be on the right bit of the planet to see it. Now, it's not just one spot that sees it because everything's moving. This line here shows you where the Earth and in fact the moon move around the sun. This is the orbit of the Earth. The Earth is moving around the sun at about 20 miles every second. This green line here, it's moving this way, so the moon is moving along like this. The Earth is moon are moving this way, and the Earth is spinning. And so if you put all of those things together, you get that at one moment, this is where you need to be, but the next moment it's here, and then here, and then here, and then here, and so on. And so what you'll get is a path that the shadow draws across the Earth. So we get an area that you can see, any given alignment with the moon can be seen from an area that is a few thousand miles long, but still only 70 miles wide. And although it sounds like a big area, it's only about 1,000th of the surface area. So what you have is that 99.9% of the Earth will not see a given eclipse. But they're not always in the same place, so they'll come around eventually. But the chances of a given eclipse being on your bit of the Earth are very slim. Now, before we go further, I want to talk about what's going to happen in 2 weeks. So this is to scale, and let's see if this animation works now. This is to scale, and the moon is in the way, and we're going to get, there's the dot. The dot is going to move all the way across the continent of the US. It's in the Pacific. It hits Oregon, goes over Oregon, into Idaho, into Wyoming, Nebraska, Missouri, woohoo, Illinois, Kentucky, Tennessee, Georgia, North Carolina, South Carolina, and out into the Pacific. Now, if you're not standing under that tiny little dot, you're not going to get to see a total eclipse. So for this one that happens this year, it's still a fairly small area that gets to see it. The other thing to note is how fast that shadow moves across the land. It will take 94 minutes for the shadow to move all the way from Oregon to South Carolina. It is moving so fast that even a fast supersonic jet cannot keep up with it. Now I want to spend a little bit of time talking about what you're going to get to see. So this is a time lapse from a previous eclipse, and if we start up here, you can probably just see there's a little bit of the sun missing. Now, if you want to watch this part of the eclipse, you need to have safety glasses. The glasses can look something like this, or they can sure I had some other ones around here somewhere. Oh, there we go. Or mostly they look like this, okay? This material that's in the glasses only lets in 1/1,000,000th of the light that hits them. And so what that means is that when you look through these at the sun, and I could, well, it's cloudy, but on a sunny day, I could go outside and look through these and look at the sun completely safely, and it will only look as bright as the full moon. The sky will look black because it's not giving off enough light for anything to get through this, and the sun will look as bright as the full moon, and it's completely safe. And you should never look at the sun, whether it's an eclipse day or not. And so for the whole of this portion where you can still see the sun all the way down here, well, then you need these glasses. Now, at the beginning, when there's just this little bite out, it's not very exciting yet. If you didn't know there was an eclipse, get to somewhere around here and you wouldn't have noticed anything. It would just look like a normal day. If you've got the glasses on, you're going to start seeing this. And in fact, around here, you're going to start seeing weird shadows because the shape of the sun affects the shadows, especially under trees. You get to about here, and now the sky looks a funny color. It's a little bit like on a stormy day when you look outside and you know that there's going to be a thunderstorm, but you can't really put your finger on why it looks weird. So what's really happening is there's enough light missing that the sky has gone to an early twilight color. So it's like the sun's just set, and it's not dark yet, but the sky is a little darker blue than normal. And all the way from about here, all the way through to it getting dark, it's going to be that kind of twilight color. It's going to get a little bit darker, just tiny, weeny bit darker as we go down here for the last 30 minutes or so before we get to darkness. But we get to here and there's still enough sun showing that if we, if we look at it without the glasses, it's going to be a problem. It also means that the sky is not dark. It's early twilight colors. And then it's going to go to full moon dark. That's going to do it in seconds. So the moon moves in the way, it blocks out the sun completely, and suddenly it is dark. And it is dark like late twilight or a full moon night. And this fuzzy white stuff pops up. I'll talk about that a bit more in a minute. But depending on where you are on the path of totality, where you can see the total eclipse, you'll get different amount of time in this darkness. But the moon keeps moving, and so eventually it's out of alignment and we start to see the sun again. So then we get another 90 minutes of partial phase. Now, during the total phase here, you don't need the glasses. If you keep the glasses on, you won't see anything. This is only as bright as the full moon. It is no more dangerous than looking at the full moon, okay? But let's look at what it actually looks like. What it really looks like is something like this. This is the corona. It is the atmosphere of the sun. It's actually always there. And what we see in this image is about as bright as the full moon. That's why we go to a darkness that's like a full moon night. And you're going to get to see all of this. But it's always there, but normally the sun is just so bright. Even with only a tiny bit of the sun showing, you still can't see this because the sun is so bright. To put this in perspective, the sun is 1,000,000 times brighter than the full moon. What that means is that even if you only have 1% of it showing, 1% of the sun showing, you'll still have 10,000 times more light coming from the sun than is coming from the corona. And so you just cannot see it until the sun is completely blocked out. So you get to see this. This is actually very hot gas. It's about 2 million Fahrenheit. And it is actually so hot, it's a plasma. So the atoms have lost some electrons, it's electrically charged, and that means it follows the magnetic field of the sun. So if you've ever done the thing where you play with iron filings and a magnet, and you can make the iron filings move around by moving the magnet, or you just put the magnet down and you sprinkle iron filings on it and they line up and show you where the magnetic field is. Well, that's kind of what this is doing. The way it's flowing away shows you where the magnetic field of the sun is. And that's actually some of the science that we can do during the eclipse. We can only view this during the eclipse. It's the only time we can do it. This red stuff here, you won't see this naked eye. Remember, at this point, you don't need any glasses on, but the sun is going to be small enough in the sky that this red stuff is just a little bit too small. But if you've got access to binoculars during the total eclipse phase, when the sun is totally blocked, it is as safe to point binoculars at it as it is to point them at a full moon. Just don't be doing it when the sun peaks back out. Okay, so the red stuff. If you've ever seen images of the sun from NASA, and they've got these big loops of gas and flares coming off the surface, That's what we're seeing. The surface of the sun is down here, but these flares are coming off and you're seeing them peeking out around the side of the moon. And they really are that color. They are red. But this image doesn't do justice to what you get to see. If you've ever taken a photo in a darkish room and you see everything fine, but your camera doesn't pick up everything because it's not so good at seeing things in dim light, and it picks up the brightest things. Well, the same thing's happening here. This is the brightest part of the corona, and so that's what the camera picked up. But your eyes are better at seeing those different levels of light. So what you get to see looks more like this. Except that this will look completely black like we saw before because you can't see it at all, there's no light on it. And then here we've got the corona extending out quite a long way, several degrees from the sun. So this is what you really get to see if you get to the path of totality. There are other things we get to see. Remember that this whole thing is only as bright as the full moon, and on a full moon night we get to see all sorts of things like bright stars. And so we will also see a whole bunch of stars. So these are what we're going to get to see. Unfortunately, it doesn't also give you the little lines that show you where the stars are. So if we have a look at this, we can see a bunch of constellations you're probably familiar with the names of. The sun is going to be, this is for Missouri, so this is showing it directly south. If you are further west along the path of totality, the sun's going to be further down here. So basically, if you draw a line down towards the east, it'll be further down here. And if you're further along towards the Carolinas, it's going to be back in this direction, okay? So this is kind of in the middle. And you can see, but the sun doesn't move on its own. All of the sky moves around. So if you're up in Oregon, you actually don't get to see Jupiter here. That will be down below the horizon in Oregon. And if you're in South Carolina, you might not see all of Orion because it's going to set before we get there, okay? Okay, so we can see the sun here. Leo, we don't normally get to see in August because the sun's in the way. And so we're going to get to see the constellation Leo. This star here that is basically the front paw of Leo the lion is a star called Regulus. I don't know how many Harry Potter fans I've got, but I bet you know some. And Regulus is kind of important in Harry Potter. Not only that, but Regulus is here and his more famous brother Sirius is down here. And we also have, so here's Orion, and so if you're in a place where you can see Orion, most people can recognize this because you've got these three stars for the belt. This star here, the opposite shoulder to Betelgeuse, is called Bellatrix, and Bellatrix is Regulus and Sirius's evil cousin. All right, enough Harry Potter. I already pointed out some planets, so you can see here we've got Jupiter and Venus. Venus is going to be the brightest thing that's not the corona, and then we've got Mars and Mercury closer in. They're going to be fainter, but you'll be able to see them. There'll be a few other things, like we get to see Ursa Major every night, we get to see the Big Dipper up here, but it's still kind of cool to get to see it during the day. Now, another thing that you may notice is that the sky is getting lighter as you get down to the ground. And that's a real effect. What you're seeing down here is, imagine you're in a car that's driving west and you're looking out front and the sun has just set and you've got these lovely just after sunset colors right in front of you. But behind you, it is already dark. Well, now you're going to see those just after sunset colors on the horizon all the way around, all 360 degrees, and it will get darker as you look up to where the sun is. This isn't like anything you've ever seen, but there are other things apart from just your vision that you can engage. There will be a drop in temperature. You think about what it's like when a cloud comes in front of the sun and you feel that relief from the high temperature of the sun, and now you've moved a big rock between you and the sun. It doesn't just stop the light hitting you for a few moments, it stops it even getting into the atmosphere. And so it cools down. It can cool back down by 10 degrees. That change in temperature, the way it drops down in temperature, means that you also get air currents generated. So you're also going to feel a breeze. There's some other stuff that happens as well. Animals and plants are going to react. Actually, that starts before we get to darkness. In that last 20 minutes when the sky is kind of in early twilight colors, if you think about what birds do in that early twilight time, the sun's set, but it's not dark yet, and birds do this swarming thing. And it seems to not matter whether you're in urban areas or rural areas, what continent you're on, with the possible exception of Antarctica, because penguins are weird. You have this kind of, swarming birds. And you'll hear people say, oh yeah, the birds go crazy. I don't think they're going crazy. I think they're doing normal behavior for that light level, right? They're used to doing this when the light is dropping. But what happens is they're flocking around and they're making lots of noise, and then it goes dark really fast, so they all land and go quiet. So you really notice this change in what the birds are doing. Other animals react too. We know that things like cows will go back to the barn or wherever they spend the night. We don't know what all things are going to do. Insects we expect to start chirping or whatever noise they make, same with frogs. And so you're going to get a whole bunch of animal behaviors. Even plants. You think about plants that close up at night. There are some plants that will actually start to close up. So there's a lot to take in. Now, I want to back up just for a second and talk about what's happening as the moon moves into place. So this is a time sequence. This is the moon here. This is the sun here. The sun is not blocked out yet. You still need your glasses on. And as the moon moves into place, we see less and less of it. If we look here, we can see bumps and wiggles, okay? That is the surface of the moon. The moon is not smooth. The moon has craters and mountains and valleys. And so what you're seeing here are mountains and valleys. But as the moon moves into place, the last bit of sunlight you're going to get to see is wherever the deepest valley is. But this doesn't do it justice. What it really looks like is something like this. So what's happening here is the sun is almost completely blocked out. We're starting to see the corona, the atmosphere of the sun. But right here, there's still a valley that's letting in some sunlight. And because that sunlight's poking through and the sun is so much brighter than the corona, remember it's 1,000,000 times brighter, this just pings and makes it really, really bright in this zone here. So this is the diamond ring. The diamond is here. The moon is moving this way, and that valley is eventually going to be moved far enough up that it blocks out the whole of the sun. So the last thing you see through your safety glasses is actually the diamond ring. And when this disappears from view in your glasses, it's safe to take them off and you're in totality. And then up to 2 minutes and 42 seconds, depending on where you are, the moon's going to move across here and this is going to get blocked out, but eventually there's going to be the deepest valley over on this side will start to let light back in. So you'll get a second diamond ring as the moon is moving out of alignment again. And that's when you need to put your glasses back on, okay? So let me just recap a little bit of what's happening in terms of what you see. You have about an hour of partial eclipse that's not very exciting. Then you have another half an hour when the animals start reacting, when the sky is changing color, and you know something's weird. And then you get to the diamond ring, and this diamond disappears. And then you have up to about 2.5 minutes in which you want to look at the corona and the stars and the black family tree from Harry Potter and the planets and the horizon. And are you cold yet? And is there a wind? And what are the animals doing? And what are the plants doing? And then it's all over. So there's a lot to take in whatever time you have in darkness. Now, I want to talk a little bit about why we don't get a total eclipse every time there's an alignment, and it has to do with the supermoon. So here I've got, this is the orbit of the moon. The moon's orbit is not a circle, it's stretched out, and the Earth is not in the middle, it's off to one side. So when the moon is at this end, it is closest to Earth, and when it's at this end, it's furthest away. It goes around every 27 1/3 days, so about once a month, you're going to have the moon go through this point. But it's only going to go through this point and be full moon about once a year, okay? So our supermoon is when the moon goes through this point, so it's closest to us, and is a full moon at the same time. You know, if you bring something closer to you, it looks bigger. You move it away, it looks smaller. Now what you've got is something that is looking bigger, and it's a full moon at the same time, okay? Now what's that got to do with eclipses? Well, if this is a full moon here, that means the sun is somewhere off there. The sunlight's coming in towards the moon. In 2 weeks' time, the moon is going to have moved to this end of the orbit, and we might have an alignment. And if it's aligned and we get an eclipse, the moon is too small. It can't block out the sun because it's just far enough away that it's just a little bit too small. And what we get looks more like this. Now this is pretty cool. And actually quite a lot of people might remember seeing one of these in 1994. There was one of these that went right across the middle of the country. There was also one of these in 2012. But what you can see here is the moon is right here, but you still see the edge of the sun. And there's so much sunlight still coming through. The sky isn't dark. You don't see the corona. You don't see stars. You don't get any of that stuff. So even though this is really cool, it's nowhere near as cool as going and seeing the total eclipse, okay? So now I want to talk about when we see eclipses. Where have you got to be? This is a map of all of the eclipses, both total eclipses and annular, where you can still see the edge of the sun, for 20 years. This is 2001 to 2020. The blue lines are where you have to be standing if you want to see a total eclipse, and the red lines for an annular eclipse. First thing I want you to notice is that most of the planet doesn't get to see either type of eclipse in 20 years. If you're not under one of those strips of color, you're not seeing an eclipse of either type. So you didn't get to see one in 20 years. The other is that they're over ocean a lot of the time. Makes sense. Most of the surface of the Earth is ocean, so most of the time they're going to be over ocean. So that shouldn't be unexpected. But it means that, you know, most of the planet is inaccessible. Most of the time they're very hard to get to. And so even though they happen, you know, twice a year, the chance of it being something that you can actually get to are pretty slim. The eclipse this year that happens in 2 weeks is this one here that goes across the US. And you can see that it's still over ocean for more than it's over land, but it's over land for a long time. And that's kind of cool. This one here is the last annular eclipse we had. So if you were in the Southwest, you might have got to see it. I took my kids down to New Mexico so that we could watch this one in 2012. So like I said, we get an eclipse pretty much every year. Last year's is this one here over Indonesia, okay? This is the total eclipses in blue. This is the last one last year. Lots of people got to see it because Indonesia has lots of people. But if you're in the US, it's a long way to go. Expensive. It takes about 30 hours on airplanes. So my husband is a volcanologist. He studies volcanoes. And you may or may not know this, but Indonesia is basically a bunch of volcanoes stuck together. So he was going there for work, and I was like, oh, that'd be cool. And then I realized that 30 hours on airplanes with my children just didn't sound like that much fun. There are many reasons why people don't travel to see eclipses. Now, if we look at the one the year before, that's up here, this one in the Arctic Ocean. March 2015, March in the Arctic Ocean. Sounds fun, right? And it's mostly ocean. This here is Svalbard, and down here we've got the Faroe Islands. So there's very few places you could actually be on land. And being on a boat is fine, but that means you're paying for a cruise, it's expensive. And if you want to do research, boats and telescopes are not a great mix. Being on land is much better. So if we look at them that have been on land, if we look at this one here, over India and into China, yeah, it's over land for quite a bit there, but it's not land that, most of that is rural. It's not going over a lot of highly populated places. So it's hard to get to. And for a lot of people, that's very intimidating. And if you're a scientist and you want to take equipment, it's hard to get permission to take it in there. If we look at this one here, it starts in Brazil, goes over Africa, and into Asia. But let's look at it in a bit more detail. So the Brazil bit's okay, but then this bit of Africa has had a lot of civil war, terrorism, coups, that sort of thing. This is Libya, this is Turkey, this is the Middle East, and this is Russia. So even though it's over land for a long time, possibly not land you want to be standing on. So a lot of the time, even though we get eclipses every year, it's not something that you're going to get to go to. Now, I want to show you another version of this. This one is now a 50-year period, but it's only showing you total eclipses. That last one had total and annular. So total is when it goes dark, annular is where you still see the edge of the sun. Now we've just got total eclipses. So this year's is this one here. And this is projecting out into the future. And this is 2010 to 2060. So it's 50 years. In 50 years, very little of the planet actually gets to see a total eclipse. So again, you're starting to see why, even though if we're counting the whole planet, they're pretty common. We see them very often. In a given location, they're very rare, and your chances of actually seeing one are very slim. Okay, so I want to go into the history of eclipses in the US. This one shows you every eclipse, total eclipse. So we're not talking about partial or annular eclipses, just total eclipses. Every total eclipse that has happened since the US has been a country. The last time we had a total solar eclipse is this one up here, 1979. Now, you can tell from the accent I didn't grow up here. But if I did, and I got to see that, I would have been in 2nd or 3rd grade. Now, my friends who are my age and come from that part of the world, a lot of them didn't get to see it because there was so much scaremongering. And so I want to reassure you that Eclipse Day is no more dangerous than any other day. It is not dangerous to be outside. It is not dangerous to do anything you would normally do. The only reason there's any danger is that on a normal day, you don't try to stare at the sun. And on this day, you want to stare at the sun. So as long as we're careful about how we look at the sun using the appropriate protective eyewear or using pinhole cameras, then there is nothing more dangerous about Eclipse Day than any other day. But there are lots of myths out there. And so then these are still going around right now. But back in '79, a lot of kids didn't get to see it because teachers had them hiding under desks in rooms with blackout curtains because they were scared. So I want to make sure that everybody knows that it's not that scary. But that one you could only see up here. So this is basically Washington and Oregon, Idaho, Montana, and into a little bit of North Dakota. The last time we had one that went all the way across the country is this one here in 1918. So we really haven't had one that's like this for a really long time. Some of you that either are from on the East Coast or were on the East Coast at the time, there's this one in 1970. There's a little one right here that is 1959, but really that's just the Northeast. So, and there's one here in 1963, and that's basically just Maine. So we've had a few eclipses in living memory, but they are sparse. Like where I'm from in Missouri, well, from where I live, there hasn't been an eclipse in Missouri since 1869, and there hasn't been one over where I live in Columbia, Missouri, since 1442. So even though they happen regularly, it's a long time between eclipses. Okay, so I want to pull a few things together. I am chairing a task force to plan for the whole country. I don't want to just plan for Columbia, Missouri. I want to plan for the entire nation. And if you want to see the total eclipse, you have to be on this path here, which is the path that that dark shadow takes across the country. We call this the Path of Totality, which is my heavy metal band name. And if you're not on this path, you don't get to see it. Now, I don't know if you can see over here, there's a very thin sliver of the sun showing. So what this is showing you is that up in Chicago, or say down in Denver, you're going to get more than a 90% eclipse, and you're going to get to see something that's as cool as this. Now, it's not as cool as going to the Path of Totality, but it's still pretty good. Even up in Maine, which is as far away as you can get from the Path of Totality and still be on the mainland US, you get nearly 50% eclipse. So I want everybody in the whole country looking at the sky in 2 weeks. If you can get to the path of the total eclipse, then it's totally worth it. It is going to be amazing, and you cannot witness the same things even if you're close by. 99% of an eclipse is not 99% of the experience. Like I said, even at 99.9%, you still got 1,000th of the sun showing. And at 1,000th of the sun showing, the sun is still giving you 1,000 times more light than the corona is, and 1,000 times more light than the full moon. The sky is not dark. So if people say, oh, we've got 95%, that's good enough. It's like, no, 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 get to the path. But if you can't travel, and you anywhere in the US, you are still going to get a good partial eclipse. So I want to bring a few things together. This is basically the same as what we just saw. But there's the Path of Totality. Here's that little dark spot going across the country. So you can see where the Path of Totality comes from, okay? At the same time, we're going to watch this go around again. So we're going to see just how big an area sees the partial eclipse. So it's the whole of the US, the whole of Canada, the whole of Central America, Greenland, the Caribbean, North and South America. And the sun is just setting over here, but even Western Europe and West Africa get a tiny bit of eclipse. England gets 4%. Even Hawaii and Alaska get 20%. So the whole of the US gets to see something. Now, the other thing is that shadow goes across. The first place to get it is Oregon. So we're up here in Oregon and we're seeing it first. And people down in, you know, Nebraska, it's not full yet. And it'll be hardly anything in South Carolina. But then it'll pass them and it'll go into Idaho, Wyoming, and so on. And so we have a time over which we see it. And so this is kind of shown here. I'm sorry this is a bit fuzzy, but you'll get the idea. So that was Wyoming, Nebraska, Missouri, Tennessee, and South Carolina. And so you can see how you've got this time effect. Well, there will be people, mostly NASA, broadcasting from all along the path. So let's say that you're in Casper, Wyoming, you'll be able to see it go full in Madras, Oregon, and it will be, you know, not quite there yet for you. And then you'll be able to watch it go full after it's gone past you as well. The other thing that this shows is, if you look at this one here for Chicago, how cool is this? Look, you get to see the sun be in this little crescent phase for actually about an hour or so. And that's kind of cool. So even though it's not as good as being on the path of totality, it's totally worth spending some time outside looking at what you see in the sky. Now, the other thing that we have to worry about is if we are, where we are on the path of totality. So the shadow of the moon is not actually a circle, but let's pretend it is. And if you're in the middle of that path, as that shadow moves over and you're in the middle here at point 2, you're going to be under that shadow for a lot longer than at point 1. So the closer to the middle of the path you get, then the longer you get in darkness. And the closer to the edge you get, the less time you get in darkness. So people are really trying to head as close to the middle as possible. Now, one of my jobs is to figure out how many people are actually going to travel to this. There are 12 million people who live on the path of totality and don't need to go anywhere. Now, some of them, like here in Missouri, we've got Kansas City and St. Louis on the edges. They might want to move because they don't get very much time. But everybody in that path should be able to see at least a few seconds. But let's look at how far away people are. So we've got 12 million on the path. We've got 50 million within 100 miles, 88 million within 200 miles, 130 million within 300 miles. This is going to keep going. The upshot of it is that the furthest you can get from the path of totality is up here in Maine. Northern Maine is 1,000 miles from the path of totality at its closest point. That means that nobody in the US is more than a long day's drive from the path of totality. Now, I want to tell you a little story about the last American eclipse, which was actually in 1991, and it was only in Hawaii. Now, that doesn't help me with this because Hawaii's hard to get to, it's isolated and all that. But they all have paths, right? So the path of totality for this eclipse that happened in 91 also hit Mexico. There were so many people flooding through the border near San Diego that Mexico closed the border. There were so many people that Mexico stopped Americans going into Mexico. And I want to remind you what it was like in 1991. In 1991, I was a junior in college. And at that time, I did not have email. I actually had no idea email was a thing. Okay? I got my first email address in 1993 when I started graduate school. And at that time, the only people who I knew that had email were other academics, right? Or people who worked in academic support. So, you know, university people. So consider 1991. Nobody's using email. Nobody's using the internet. Social media hasn't been dreamt of yet. And yet there were enough people flooding through that border that unless you had a reservation for a hotel, they would not let you into the country. They couldn't handle the crowds. Now I want you to consider that we have this path of totality here. We have 350 million people who are going to know about it and no borders to close to stop them from coming. Scared yet? And even just considering who's close in. So remember that it was 4 times as many people within 100 miles, 7 times as many people within 200 miles. That's people who don't even have to drive down and find somewhere to stay. They can just drive down on the day, probably. We'll see. There are other things that we consider. And so this is actually showing you what is the closest point for people on the center of the Path of Totality. So as we look along here, you can see that there are a lot less roads up here, there's a lot less population, and as you head down into the east, there's a lot more population, there's a lot more roads. But this is basically showing you, let's say we take this point here, let's say this point here, which is probably Columbia, South Carolina, and this is going to be the closest place for all the people along this blue line. And this is based on where the roads are, right? And if we consider that, that's actually going to be the #1 busiest place, just in terms of how much population could get there, okay? But even if we consider, say, St. Louis or south of St. Louis, where I-55 crosses the path. So somewhere right around here is where, this is it, I-55 crosses the path. And that is the closest place for nearly 14 million people. If we go up to Casper, where you have a lot less people, so this is Casper right here, and we basically got I-25. So that's bringing people up from Colorado. Actually, that's this one. This one's Casper. And it's bringing people up from Casper up to see the eclipse. It is the closest place for 9 million people. So, you know, as you're looking at this, even this isn't the only reason that people will choose to go, it's the closest place, but it gives you an idea of what sort of numbers you should expect. And we think that a doubling of the population on the path is not being alarmist. In fact, we're probably underestimating. So it's going to be busy. But that's not the only reason that people choose where they're going to go. So this map is showing you cloud cover. Now, I like this map because it lets me explain the difference between accuracy and precision. And I'm a nerd, so I like to explain that sort of thing. Let me just talk about what the map is. It is a color scale for how thick the cloud is. So if it is blue, you have no clouds at all. So this dark blue means you can see the sky and there's nothing stop blocking your view. No clouds, no nothing. If it is red, you cannot see the sky. What I mean by that is, as an astronomer, clouds are not in the sky. Clouds are between me and the sky, right? I don't like clouds. They get in the way of me seeing the sky. So when it's red, it means the cloud cover is 100%. You cannot see the sky at all, okay? The way that this map was made was, it's basically the cloud cover at 1:30 p.m. for each location for every day in August for the years 2002 to 2016. So that's 15 years of data and all 31 days in August, and then it's averaged. And you can see that on average, it's better up here in the Northwest and much worse down in the Southeast. But let's talk about what's going on here. First of all, when the eclipse hits right here, it's going to be 10:16 in the morning. And on the coast in Oregon in the morning, you're going to have cloud. So this isn't precise. It's accurate because it reflects the data that was used, but it's not precise because it doesn't account for where this deviates from what really happens, okay? As you cross over from this coastal area over the Cascades and into eastern Oregon and also then Idaho, it really is this good, except that there's not enough population for them to have amenities. So if you're up in Oregon, that's great, but first of all, it's been full for a while, and it's also somewhere that, you know, they really don't have that much infrastructure. There aren't that many roads, there aren't that many places to stay. So yeah, it's great, but have an RV because there won't be enough restaurants, there won't be enough hotels, and there certainly won't be enough toilets. So take your own. As we head down here into Wyoming, this is really popular here because this is the Tetons. Who doesn't want to see this near the Tetons? But actually that affects what the cloud cover is. As we get into Nebraska, it's actually, this is pretty good, and the sun is really, you know, it's about 1 o'clock when it gets to here. And we're starting to see the onset of worse cloud. But if we look at this, so for instance, in Missouri, it's not this bad in August. But that's because, again, this is accurate but not precise. It doesn't account for different types of cloud. So cirrus is what we get a lot of the time in Missouri and also into Illinois and Kentucky. So what we get typically in this little bit of the country in August is 10 days with 0 cloud, 10 days with cirrus, and that's the nice wispy stuff. So you can still see through it. You might have, you know, maybe you can't see Venus or you can't see Jupiter or you miss Bellatrix, but you'll see most of what's going on. And then you have 10 days that suck and you can't see the sky. But what that means is that instead of being this yellowish green up here, we should actually be down about this blue color down here. And again, that's to do with precision versus accuracy. There's nothing wrong with the data, but it's not accounting for how Cirrus is more transparent. We get down into the southeast, it gets much worse. And that's partly because we're in hurricane season. And so, you know, it's likely to be cloudy in South Carolina. Now, in South Carolina, it is, it's going to be busy anyway. It is the closest place for all the people on the East Coast here. So even though it has the worst chance of clear skies, it's still going to be really busy. Over here is got the best chance of clear skies, but they don't have the amenities and it's hard to get to. So basically we get kind of a spreading out because there are pros and cons for everywhere along the path. And so we're going to get something like a doubling. All right, I have one more thing after this that I want to show you, and then I'll answer questions. So this is a website that we put together that has all sorts of information on it. We were charged by the National Science Foundation and the Astronomical Society to put together resources. It has safety advice, it has maps of what's going on, it has how to take photos, it has resources for teachers and all sorts of things. So this is the website that's kind of a hub for everything you could possibly want. Including safety advice that's endorsed not only by the National Science Foundation and NASA, but also by the American Academy of Ophthalmologists and the American Academy of Optometrists, because we really want you to believe us about our safety advice in your eyes. Okay, last thing I'm going to do, and then I'll stop talking. This is an animation of the whole path. So what you're seeing here is that shadow is not a circle. That's the shadow of the moon. It's moving, but you can't tell because it's over the ocean and there are no landmarks. There's the coast of Oregon, and it's going to hit the coast of Oregon right there. And so it goes, there's the Cascades, goes over the Cascades. Look, there's nothing in Oregon. So, you know, you can go there, you just can't eat or sleep or pee. Same in Idaho, although Idaho Falls is going to be really busy. And then here we see Jackson. Jackson's been full for years. And then Casper, because of it being on I-25, is going to be busy. Alliance, Nebraska is where I would go if I didn't already live on the path, because they have Carhenge. And I can't help but feel that that would be a cool place to watch an eclipse. You can see that the number of cities starts to increase as you get down here. Once you hit Missouri, you've got a much bigger network of road options and also many more cities. So that's where there's advantages to being at this point. As we cross the Mississippi, Carbondale is close to the longest duration. The most symmetric is here in Hopkinsville. Nashville is the biggest city wholly on the path, although there are more people in St. Louis on the path than in the whole of Nashville. And then the bits of North Carolina and Georgia are hard to get to, and then it goes out through South Carolina and into the ocean. And I'm going to stop talking and let you ask me questions.
Okay. What I'm going to do is, like I said, for the individuals, you can type it in the chat room, and I'm going to call on centers and see what you have to say. So I'm unmuting people as I go. And we'll start with Susan up in Minnesota. Are there any questions there?
Are there any questions?
What is the website?
What is the website for them to go to for all the information?
I'm going to type it into the chat window.
I'm typing it right now.
Oh, okay. There's a question in the chat window that is, what if it's raining that day? Okay, it's still going to go dark. So if you're off the path of totality, it's not going to be super exciting because, you know, it doesn't really get dark. It'll get darker than usual, but it doesn't really get dark. But if you're on the path of totality, it goes dark like a full moon night. So it's still going to get dark. You're still going to get colder. There's still going to be animal reactions. You won't get to see the things in the sky, but that's the only issue. So it's still cool.
Any other questions, Hopkins?
No questions here, thank you.
Okay, thank you. Our newest one, St. Mary's. Any questions from St. Mary's?
Questions here, thank you.
No questions?
No questions.
Okay. No questions? All right. Let's see. Who else do I have here? Who am I missing? Maryville went off, I believe.
Oops, sorry.
Okay. I'm not seeing any of the other centers right now. Let's see. Clay County, you have any questions?
No, we don't. Thank you. It's wonderful.
Thank you.
Okay, individuals. Any questions in the chat room for Angela?
So it says that somebody asked about watching the whole thing. Basically, NASA TV is the way to go. NASA is working with some other organizations, and so, but they will have people, it's not quite, it's basically 7 locations, plus they're pulling in some others. So there's going to be Madras, Oregon, Casper, Wyoming, I don't think they're in Nebraska, Jefferson City, Missouri, Hopkinsville, Kentucky, Carbondale, Illinois, Nashville, it's not Nashville, it's Clarksville, and then Charleston, South Carolina. So they're not going to be everywhere, but they're going to have places all along the path that they'll be broadcasting from. They're also working with other units. So for instance, here in Columbia, we will have an ABC station that is part of a consortium that also has people in Nebraska, St. Joe, Nebraska, and Idaho. And so there'll be some feeds going to NASA. And the reason that we're doing it through NASA TV is that that way it shouldn't rely on internet, because I mean, there's going to be some internet outages, but NASA can generally handle that. And so we don't want it to be on, you know, if it's on, say, discovery.com for the Discovery Channel, they'll probably lose their access. I mean, it'll probably crash. So NASA TV is definitely the best way to do it, which is usually part of the standard package.
Very good. There was one, is it better to watch it at a planetarium or with other people? I saw that one.
Okay, so honestly, a planetarium is not necessarily the best way to do this. If you are able to be in totality, it's honestly good to be with other people, because there's a big collective. There's often casting, because people just can't help themselves. It's so awesome. It's like, and then. So from that point of view, I think it is, you know, it's a very human thing to be impressed by something like this. If you've ever been to the Grand Canyon and you've seen pictures of it, and then you see it in the flesh, like, well, you know, this is like that, only there's a, you know, volcano erupting in the middle and it's in the sky. So, you know, it's impressive, and it's kind of nice to share that. But honestly, if you are on the path of totality, as long as you are in a place where you can see it. So for instance, here in Missouri, it will be almost directly south. If you're out in Oregon, it's going to be off to the east. If you're in, or southeast, and if you're out in South Carolina, it's going to be southwest. So, you know, as you're looking for where to be, as long as you can see in the direction that the sun is going to be, and there's lots of ways to figure that out, wherever you can see it is the best place to be, frankly.
Another question was, will the website that you gave them, will it track the eclipse?
It will not be tracking the eclipse. It will provide the links to the places that will be doing that. So we're meant to be a hub to facilitate, but we're not actually doing that. And so, and like I say, NASA is the best way to track that, unless it's a commercial thing. So NASA cannot put links to any commercial companies. So then that includes TV stations, right? So we will be the place you can look to see, oh, where can we go and look at this?
Okay. Another question is that I'm in Southeast Florida between Palm Beach and Fort Lauderdale. Is there likely any place I would be seeing this? If so, what time?
Okay, so if you're in Florida, you're not going to get a total eclipse, but you are going to get a partial eclipse, and it's going to peak mid-afternoon. So the time that you're going to see the most of the sun hidden, and it's still going to be more than 50%. It's probably a 60% eclipse down there, and that's going to be sort of in the 2 to 3 p.m. range.
Okay. Any other questions?
Extra time dropping up there.
Anything else for Angela?
Let's go.
Anything else, Lynn, in the chat room I'm missing?
Well,
Okay.
oh, go ahead.
I can offer some feedback. For me, it was difficult to trace where you were pointing to because the blue, whatever the flash change was dark. If it had been red, it would have been easier for me to track what you were pointing to.
Oh, the problem with the pointer?
Yes.
So I'm not sure how I can, I'm just using the cursor. So I'm not sure how to fix that, but I'll think about that. Thank you.
And there might be some tools, Angela, that Zoom has that we might have been able to introduce you to.
Yeah, there are, and I should have thought about that, but you know. Anything else for Angela? Okay, to everybody, I have recorded this, and as soon as it spins around from Zoom, because I recorded it in the cloud, I'll send it back out, including to you, Angela, so you can have it.
Thank you. Do you have any objections to posting it to YouTube?
So thank you, thank you, thank you.
We definitely can, Angela, if you'd like that.
We'll put it on.
I can do it. So, but yes, I'd love it.
Okay.
Yeah,
Post it to YouTube. Okay.
we can post it to YouTube as well. All right.
Excellent.
All right. Thank you. You were well reviewed. My sister was right. So thank you. Thank you, ma'am. All right.
All right.
everybody else,
Thank you.
links. Thank you.
Bye-bye.